Here goes nothing. Let's do it. I'm a Helu Hazelton from the 403 to the HAZ, Mr. Nelson here. Shalom. Okay, Pre-Cal 12. We're learning about, or I guess we're extending our knowledge of trigonometry. And in the last video, we just learned about radians and how we can either work with degrees or we can work with radians. So we're going to be working with radians mostly moving forward. And we know that 90 degrees is the same as pi over 2, 180 is pi, and we know that we can convert between the two using our little rule that 1 degree is the same as pi over 180 radians, and that 1 radian is equivalent to 180 degrees over pi when we want to convert between radians and degrees. Okay? And we like to use pi in our radians because that just works well with our unit circle. So let's start talking about our unit circle now, based on what we know. I know that a unit circle is based on the premise of a radius of 1. Unit circle, 1. Unit, 1. So when I'm working with a unit circle, my radius, my hypotenuse, my radius is always going to be my hypotenuse. It's always going to have a length of a single unit. Okay? So when my radius is perfectly flat on the x-axis in quadrant 1, then that point on this point on the circle, point 2 pi, the point at an angle of 2 pi or 0, is equivalent to the coordinates. Now remember, any point is going to have coordinates x, y. So in this case, my x is 1. It's the exact length of my hypotenuse or my radius. And then I have 0 for my y. I have 0 vertical. When that radius moves all the way to the vertical position in quadrant, between quadrant 1 and quadrant 2, my x has gone to 0. There's no more x. But my y is the same length as my radius or my terminal or my arm here. So that coordinate is going to be 0 for my x coordinate, 1 for my y. When I move down here, now I'm into my y has become 0 again, and I'm into the negative x. So I get negative 1, which is the length of my radius, 0. Down here, my x goes to 0, but my y goes to the length, negative 1. So the sign is important because that tells me what quadrant I'm in. So I'm in the negative y now. So those are points, those are the 4 main points that we kind of start working with. Now, we can start working with different points along the circle by using what we know about trigonometry. So this will create, this point here will create a circle which has a y coordinate and an x coordinate. Okay, and I know from trigonometry that x squared plus y squared, my x coordinate squared plus my y coordinate squared will equal to 1, or 1 squared. And so this is what is the basis for how we're just going to start solving problems. So if I go into the textbook problems, it asks me, okay, it asks me things like, are the following points on the unit circle? How do you know? And they'll give me coordinates like negative 3/4 and a quarter, a positive quarter. Now, based on what I'm seeing here, this is my x coordinate, this is my y coordinate. My x coordinate is going to be somewhere in here. It's in the negative, right? So I'm assuming it's going to be, if it is on the unit circle, it's going to be in this side because it's negative. And then my y is positive. So that's telling me I'm probably going to be, so positive y, negative x, I'm going to be in quadrant 2. Just based on looking at that. But to figure out if this is on my unit circle, I have to figure out if x squared plus y squared is in fact equal to 1. Because if it is, then yes, it's on that unit circle. So let's try. Negative 3/4 squared plus 1/4 squared is equal to what? Well, this is the same as 3 squared over 4 squared plus 1 squared over 4 squared. The sign doesn't really matter so much because when it's squared, it's going to disappear. And this gives me 9 over 16 plus 1 over 16. And if I do the math there, I get 10 over 16. So guess what? This is not actually a point on my unit circle. Let's try a different one. Let's see if this next point is on my unit circle. What if I had negative 5 over 13 for my x and 12 over 13 for my y? Is this on the unit circle? And am I still filming? My goodness, I'm still filming. Who could even imagine? So let's figure out if that's on the unit circle. So again, my x is negative, so my x is going to be in the negative x quadrant, because this is negative x over here, positive x, positive y, negative y. And then my y is positive, so again, I'm assuming I'm probably going to be in quadrant 2. Negative x, positive y leaves me in this quadrant. And let's see what I get. So I'm going to do x squared, so 5 over 13 squared. The negative will disappear with the square, plus 12 over 13 squared. And when I do the math, I can distribute that square. So I get 25 over 169, plus 12 squared is 144 over 169. And when I add these two together, I get 169 over 169, which is 1, which tells me, yes, this point is on my unit circle, and it's going to be somewhere with a big Y and a small x. It's probably going to be somewhere up here, right? Because this has a nice big Y, almost 1, almost a full 1, and then a pretty negligible Y. So that's that. So what if they told me to figure out some coordinates? Okay, so this was just figuring out if coordinates were on the circle. What if they said, okay, you have a coordinate of 1 over 4 for your x and y, and it is in quadrant 1. What is the y coordinate? Okay, well again, we're going to come back to using this guy. And to do that, I'm basically solving for y. So if I solve this, I'm going to get y squared is equal to 1 squared minus x squared. And it's in quadrant 1, which means that my y should be a positive y. This is going to help me figure out what the sign should be. If they said quadrant 4, quadrant 4 would be here. It'd still be positive x, but now I know that my y should be negative. But in this case, we're up here. We're in the nice positive left. So y squared is equal to 1 squared minus 1 over 4 squared. Y squared is equal to 1 minus 1 over 16. 1 squared is 1, 4 squared is 16. Now I need to convert these into similar angles. So this is equal to 16 over 16 minus 1 over 16. I just replaced 1 so I can use fractions, and I get y squared is equal to 15 over 16. Therefore, y, and then I'm going to take the square root of both sides, so square root here to get rid of this, square root here. So y is equal to the square root of 15 over 4. And I am going to check my answer because I am not feeling very confident because I have never taught this. So let's just make sure I ain't crazy, girl. Oh, that was number 3A. 3A off 186, wrong number, 3A. Holy crap, okay, 3A. Root 15 over 4. Hooray for me, Billy. Okay, let's do another one. Okay, we've got coordinate x and -5 over 7 for y, and it tells me it's in quadrant 4. And quadrant 4 is right here. Quadrant 4. So quadrant 4 is positive x. It's negative y, but it's positive x. So now let's figure out what x is. I get x squared is equal to 1 squared minus y squared. X squared is equal to 1 squared minus 5 over 7 squared. I can ignore the negative because it's going to disappear with the square anyways. X squared is equal to 1 squared minus 25 over 49. And so if I'm going to be able to subtract these, I need to convert 1 squared is 1, as a fraction out of 49. So x squared is equal to 49 over 49 minus 25 over 49, which is equal to, I don't feel like thinking, 49, what's going to be 24, right? 24 over 49. And then if I take the square root of x squared and of this, I get x is equal to the square root of 24 over the square root of 49, which is 7. And it's going to be a positive x because it's in quadrant 4. Okay. And that is all I'm going to teach for this video. The next video we'll start dealing with particular points of importance around the circle. Specifically, I mean the 30-degree mark, the 45-degree mark, and the 90-degree mark, which work out to pi over 6, pi over 4, and 60, and pi over 3. But we will get there, okay? That's in the next video. I'm just happy that I got through this one without it dying on me. Incredible.